I've had some viewers been watching some of my early videos. I mean, really early, like the second one and the third one and the fourth video. Suddenly shot to my top 5 videos this in the last 30 days, and I watched the addressing modes one, and I thought, oh my god, did I really do that? So yeah, it's yeah, they were the back in the days of me just toying with the idea of becoming a YouTuber and I didn't even think about becoming a Twitcher then. But yeah, so addressing modes. So what we're going to do is we're going to talk about addressing modes, and then we're going to do some small examples and trying to make the examples hopefully understandable for the beginner. So we're going to use Kick. We're not going to use CPS. We're going to use Kick because it's exactly the same thing in Kick and CPS. I don't understand it, mate. I tell you, the first 5 videos are in the top 10 in the last 30 days. I have no idea what's going on. I don't know if the 6502 is back in favour again, but yeah, my tutorial 1 to tutorial 6, I think it is, are in the top 10, and I can't believe it. In the last 28 days, they're in the top 10. It's ridiculous. So I thought we did last time we did the Hello World. Yeah, we did an updated version of the Hello World, and that seemed to solve a lot of people's issues, because I've had some comments and emails saying, thank you very much for doing that. When is it coming out on YouTube? Because I think it's gone off Twitch now. So I'm gonna see if I'll edit it and get it out there. So we're gonna do addressing modes. So I have dug out from my GitHub my slides that I did right at the very start, and I thought, right, I'm gonna do them again. I'm gonna use them again. So addressing modes. Right, addressing modes are a mode of addressing. And what I mean by addressing is how the CPU gets its data. How do you tell the CPU to get the data it's going to work on? So there are many ways of getting data. There are telling the CPU, this is number 1. Use this number, which is number 1. Or there's a mode where you tell the CPU, go to memory address 100 and use that number. And then there's addressing modes that says, go to memory address 3278, use that number. And then there are addressing modes that seem to cause a lot of confusion, which is, I am not going to tell the CPU which location that I want to get the number from, but I'm going to tell the CPU where the location is, and then it can figure out where to get the number from. And that seems to cause a lot of confusion, because it is very confusing. So let's start with a typical instruction, LDA. Now the LDA instruction uses near enough every addressing mode bar 2. Yeah, I think it uses every addressing mode bar 2, or maybe 3. No, 2. We'll see when we get there. So if you're using the load accumulator instruction, or LDA, you can say load the accumulator with this number, and that is the very first one, which is the addressing mode immediate. You are telling the 6502, here is number 10. This is what you're going to use. And the CPU will load 10 into that appropriate register. So in this particular case, it's the accumulator. And it's as simple as that. I'm telling you, this is 10. Use it. There's also where you can tell it to load a number from 0 page. Now, we're going to get into the word 0 page and absolute, right? 0 page is memory locations from 0 to 255. That's what 0 page is. It's officially called page 0 in memory because each page in memory is 256 bytes, which is from 0 to 255. So when you say, I'm going to use addressing mode 0 page, it means that that instruction will only do enough cycles to look at the first 255 bytes and say, right, I'm getting that number from there. Then you've got the indexed version of 0 page, right? Which in this particular case is X. So the X register will have a number between 0 and 255. And you will tell the accumulator, please load the 0 page location 6. And I've already told that the X register is 10. So please load 6 plus 10. Well, we'll get there. We'll get there. I've got slides that are going to go through this. Absolute addressing means I am... Yes, 0 page is faster and uses less cycles as well as fewer bytes. Absolute is I want to read a memory location from 0 to 65535. That's the mode that allows you to read the entire memory stack. We've also got it indexed. And then the final two, which is indirect loading, we will get to in because I'm not going to try and explain it layman terms now because it's not going to happen. So, first thing. So we've spoken about immediate mode. Yeah? Dead easy. Load 10 into that. That's all I'm going to do is load 10. So, first mode of significance is 0 page. So like I said, 0 page lives right at the start of the memory stack. Yeah. So all this is 64K. So on the C64, at the top we've got the kernel, then at D1000 we've got the input output, at A1000 we've got basic ROM, and then from there down it's all RAM that we can use. But there are some things that we can't use because system uses it, but we're not going to get into that. Yeah. So 0 page is the very first page of the memory stack. So it's the memory stack values from 0 to 255. The memory address is from 0 to 255. Not anything more. And you can't go less because it's impossible. So what you're telling the computer, what you're telling the CPU is load the accumulator with the 0 page location 32. And what it does, it goes to the 0 page location, which is this bit. So I've expanded it, part of it out. Yeah. And it's looked at 32, which is 2B, blah, 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 which is here. And loads D6, which is in that memory location, into the accumulator. And that is all it does. Simple as that. You can't get much simpler than that. Now we start getting more complicated when we go into the next one. Now this one is exactly the same as load 0 page. The only difference is now you're telling the CPU 22 is my base. This is my base location I want you to look. Then add whatever's in X. So let's say, as the slide says, X has got 6. We're telling the computer to look at 0 page location 22. And X is 6. So effectively you're telling the CPU to look at 22, which is highlighted in yellow, but offset it positively by 6. So you go 1, 2, 3, 4, 5, 6. So it's looking at this location and then takes that value from there and loads the accumulator. So it allows you to say this is my base point and load the memory location with the offset of x. So if x was 0, it would load 22. If x was 1, it would load 22 plus 1, which is 23. And the example on the screen, 22 plus 6, which is $28. And you can carry on up to 255. The caveat is, remember, we're loading 0 page. If you are doing LDA, FF, this is the extremes. This is the extreme condition. If you load LDA with FF and then give it X of 6, it's not going to look at memory location 105. It's going to wrap round and look at memory location 05 because the instruction is load from 0 page, not load from page 2 or page 1. It's load from 0 page. So keep that in mind when you're using indexing on 0 paging, because you cannot go further than FF. So in here, in the example here, if we had load 22, comma, let's see, 230. Let's say 230. What's that in hex? 232 is F0? No. Get the calculator out, John. My brain's not working today. Right, 230. E6. So if we told it to load A with E6, comma X, and we made X, 22, comma X, and we made the X register E6, it would wrap round. It would wrap round. And so it would load memory location to... No, it would load more than that, wouldn't it? Be 8 or something like that. So keep that in mind. So that's 0 page. Now, absolute. Exactly the same functionality as 0 page. The only difference is we can look at the entire memory space. We can look at the entire memory stack from 0 to 65535. So when we tell the CPU to load from 32FF, it goes to the space in the memory. So this is roughly around 32FF. It loads the value, puts it in the accumulator. That's it. Exactly the same as 0 page, but this time we can look at the entire memory stack. Simples. Next one. Just like 0 page, you can load from your base point, in this case 32F0, have an X value of OB. It will look at 32F0, add OB to it, and then looks at 32FB. Now with 0 page, if you went and crossed into if you loaded the X value that was bigger than the page, it would wrap round to the beginning. With 0 page, it doesn't. It looks in the next page. So if I put X at F0, yeah, F0, it would actually do 32F0 plus F0, which is 33E0, and would load up to that memory location. But you can only offset it as far as 255. You can't offset it by any more. Hello, Stuart. So that is absolute addressing offsetted by X, and it's called index by X, but it's literally offset. You offset your base position with the value of X. Yes, FF is it's the same situation as 0 page, because you can't have 1F10000. It wraps back round to the beginning. I mean, we can try and demonstrate that when we do the thing, but yeah. You can't hear out. Well, my mic's working, and I've been talking for 15 minutes with no mic on it. Anyway, right, here is the first of the ones that really confuses people. And it's called zero. This is called indirect mode indexed, right? So indexed indirect mode. And what it means is we're not telling the CPU exactly which memory location to go and get the value from, right? Like absolute, you're telling the computer, go to 32F0, get me that number. With indirect mode, you're saying to the computer, I want you to look at this location in 0 page, work out the memory location from that location in 0 page, and then go get me the number. Oh, by the way, offset it by the X register. I don't know if I made that easier. Oh, let's see. How can we say this? Okay, here we go. Yeah, the slide examples is okay. So let's imagine we have 255 post boxes, yeah? And each of the post boxes has a letter that needs to go to an address, yeah? Goes to a house. And your job is to go to a specific post box, read that letter, work out where that house is, and then go to that house and ask how many people live in that house. Yeah? So, like we've got on the example on the screen, we want to go to post box $20. Right? But hang on. We've been told that we need to go to the 6th, or in this one, B, the offset of B. So you go to the post box 20, and then you go, right, I've got to count up by 13 or OB. So you count up 21, 22, 23, 24, 25, 26, 27, 28, 29, 22A, 2B. Right, grab that letter. What's the house? Right, oh, okay. It's 1541 Pennsylvania Avenue. Right, let's go. So you go to the house, knock on the door. How many people live in this house? 3. That's the number you load into the accumulator. So that's how this works. You are telling the computer to look at a memory location, and then you're telling it to offset it by what's in X. So if X is 6, you're saying go to $20. Then 1, 2, 3, 4, 5, 6. Right, I'm looking at $26. Work out the memory location from $26. So it uses $26 and $27 because some memory address location is 16-bit, not 8, so it needs 2 bytes. Grabs the data that's in those 2 bytes, converts into an address. So, like on the screen, it's gone and loaded 30AC, and because 6502, the numbers are the wrong way around, so you swap them over. So it's going to look at memory address AC30. So it looks at AC30. It's got FF. That's the value it loads into the accumulator. This addressing mode is probably the most difficult addressing mode that's there to understand. But once you understand it, it's okay. But it's one of the difficult ones, if not the difficult one, because sometimes it throws me, and I've been doing this for God knows how long. The other addressing mode is called indirect Y addressing. Now the indirect Y addressing is exactly the same as the other one. The only difference is, remember your line of post boxes? You're going to post box 20. You're not counting up, you're not counting down. We are looking at that one and that one only. Take the envelope out. Right, we're going to 24 Burton Road. Then you go to 24 Burton Road, but then you offset that 24 Burton Road by Y. So Y is containing 4. So you're not going to 24 Burton Road, you're going to 26 Burton Road. And then finding out how many people live in that house. And that's how this indirect Y indexing works. You tell the computer, right, go to memory location 20, work out what the address is there. So we're looking at 20, and 20 in this case is exactly the same thing again. 30AC, and remember we swap them over, so it says AC30. We look at memory address AC30, and then we grab FF or AO. We don't grab FF or AO. FF is our pointer where we're going, and then we offset it by 4, which is in Y. So FF, then it looks at 32D6B1 A0. That is the value we grab and put into the accumulator. So they are the most common in addressing modes. I mean, I spoke about that in the video. There are 2 other types of addressing modes, but they are unique to certain instructions. You have got the relative addressing mode, which is unique to branching, right? So nothing else uses relative mode, nothing else. Only branching. So when you say branch if not equal, branch if equal, branch if carry set, branch if carry clear, the number that's next to it is normally the address. But it's not really the address. It's a relational number to where you are now to where you want to go. So if you say branch if not equal plus downwards, then instead of, if you're, let's say the instruction's at 1000 and you need to go down and you need to branch down to the instruction at 1010, then it doesn't do branch if not equal to 1010, which you would see in an assembler. Yeah, it actually says branch if not equal to 10. And what's that is a relational number based on the current program counter. It adds 10 to the current program counter, which is 1010, and that's where it fires the next instruction. Conversely, when you're going backwards or up the memory chain, if you say branch if not equal to 9F0, which is going backwards, you don't say branch if not equal to 9F0 like you do in the assembly source code. What is actually assembled is branch if not equal, whatever that instruction is, and it is, let me work this out now. Get it right, John. I think it's F1. I think it's F1 because I think it's one's complement, and what it does is it's a one's complement of -10, which is F1. I think. I'm sure someone will contradict me if I'm not right. And so you would see branch if not equal F1. And what's that's telling the CPU is, oh, it's bigger than 128, so I'm going backwards. So I need to work up the memory stack. So it always looks behind itself. So that's relative mode. There is another one called jump indirect. So for the jump instruction, yeah, the JMP instruction, you have jump to the absolute value. So jump to 1010. That's an absolute value. But you also have the indirect one, where it says, where you say, I would like you to jump to the address that's specified in this address. So you would have jump, open bracket, and then you would put the address where your jump location is stored. And then it loads that those 2 bytes out of that memory location and the memory location +1, loads those 2 bytes, flips them round, puts it in the program counter and says, right, that's my next instruction. That effectively jumps to another location. Now, jump absolute addressing is the one that you will use 99.9999999% of the time. Because you are going to jump to a known location. You are going to jump to that location. But is it no, minus 10 in hex, mate. Not minus 10 in decimal. So, but jump indirect allows you as a coder to be able to say, I want you to jump to whatever I put in this memory location. Now, we use an indirect jump in Hunchback. Yeah, we use an indirect jump when we are evaluating the bad guys. Yeah. And so we depending on what bad guy is, we load the memory address of that routine, and then we store it in a memory address, which then we do an indirect jump of. Yeah, buddy. You come to see how I'm doing. Alright. So, and it allows you to have the full flexibility of the jump without the rigidity of the absolute jump. Yes, yeah. So, let's do... Yeah, okay. So, and that's an indirect jump, but you will use that instruction 0.000001%, maybe less, because I've only used a jump indirect 30-40 times in my lifetime, based on how much I've coded in the last 30 odd years. That is nothing. It's probably one of the instructions that gets used very rarely, just like the break instruction. The addressing mode that gets used very rarely, which is the indirect jump. But they are all the addressing modes. Yeah. So remember, so you've always got to remember there are two main states. There are the 0 page addressing mode, which is load from 0 page that location, load from 0 page comma X or Y, which is offset, absolute, which is that location. Difference being is not that you can load from all the memory stack compared to the 0 page stack. And then you've got the indirect. I want to get that number out of memory via the back door. Yeah? Or the house, how many people are in that house based on the postbox number. They are the addressing modes. Now, in your day-to-day life, you'll be using immediate the most, 0 page third most, absolute second most, indirect. You'll use it, but you'll use indirect comma Y more than indirect comma X. It's very rare that you actually see an indirect comma X instruction in code. The only time that you see some indirect comma X is where you're doing tuples, when you're using tuples and stuff like that, where you've got an array of memory locations that you want to run over. That's where the indirect comma X comes into it. But I've not used indirect comma X for a long time. I think the last time I used it was for the OSK monitor. I think it was the machine code monitor. So let's see if we can do a few examples of these addressing modes. So let's create a new file. let's addressing modes. Right, let's grab this. We'll use this as our example. Right, so we're going to use this as our example, and what we're going to do is, as you can see, we are using in our Hello World example, we are using immediate modes. We are loading numbers directly into the accumulator, and you can show that by pressing F6. We'll let it run. There you go, it works. But when we come to look at our dump, there we are loading 16 and 08. These are the numbers. This is immediate mode programming. We are telling the computer that was 08 and that was 16. Now, if you want to use different other one, the absolute addressing mode, so we will then create a so we're going to put that wherever this memory location is into here, and now we are going to do this. So this is immediate mode. Now we're going to use absolute mode, and the difference is we are going to load. So this is the big number 1. And 0. And the only difference we're doing now is we're telling load Y with that address and load A with that address plus 1, because this is a 16-bit number. So we should end up with the same, and I've got them the wrong way around. We should have them with the same number. It should come out now. There we go. The only difference there is we are not telling the CPU to load 10. We're telling it to load whatever's in this memory location, which in that memory location is the address of this text. Yeah? So that's the difference between immediate and 0 page and absolute. Yeah? Now, we could, if we wanted to, I think you can load Y, X. Hang on, let me just check that. Let me just check that. I know there's some that you can do. LDY, where are you? Yes, we can. Right. So what we can do, the other way, the other addressing mode is indexing, yeah? So we're going to say load X with 1. So we're loading X with the absolute value 1, which is using immediate mode. And then we can do this. Yeah? So we're loading Y with this memory address, but because we've put 1 in X, it's going to offset it by 1. So we should still have Hello World. Yes, we do. And that's because we have told the CPU load the Y register with whatever's in this base address plus X. Not what the value is in the base address and then add X to it, but what the base address is and then add how many X there is. So in this case, it's 1. And that's what you call indexed addressing. Yeah? So that's index addressing in absolute mode. Now, to do indexed indirect index, it's a bit more difficult to try and demonstrate in this example. How we're gonna do this? How we're gonna do this? We will rem that out, and we will do. Is it virtual? .virtual, isn't it? No, that won't work, will it? No. How am I going to demonstrate that? Right. This is how we're going to do it. Right, so we need to prime the 0 page, so we're going to prime it with that. That should do it. Then we're going to load that, and we're going to JSR $FFD2. First, we're going to say branch if equal to exit. INY jump looper. Oh no, we don't need that. Right, so we've set our mailbox to look at this position here, yeah? And then we're going to load whatever's in this, and we're going to offset it with whatever Y is. So Y, when it starts, is 0. And so it'll start at this location there, so it'll start at H. We'll print out H, we'll increase Y, and then it goes back round. But this time, it doesn't look at H, it looks at the base location plus Y, which happens to be 1, then it sees E, then prints that out, and then it comes back, and then it sees L, and prints that out. So we should be able to have the same thing. There we go. That is how indirect Y. Now, I'm not going to do indirect X, because to try and do an example like that would take way too long. But that's addressing modes. For beginners, are there any questions? Hey, Stacy. No? It's only a beginner's thing for the guys that are starting out, but that's basically, in a nutshell, the more significant addressing modes that you will come across. I mean, I've talked about all of them, but I've only demonstrated 4, I think. But they're the ones that you will come across the most. Right. Okay. End of that tutorial. I'd like to thank all the patrons that are contributing to my channel. Without you guys, I wouldn't be able to do what I'm doing right now. Thank you very much.